evening, folks. Can you hear me? Some yays or nays would be very good. I only want the music to be nice and soft in the background so that there's something going on, but I don't want it to interfere too much with what I'm saying, even though that might actually be appealing to some of you. Music slightly overpowering voice. +1 and music overpowering. Okay, I've just dropped the music volume down a little bit. Is that acceptable? Or is it not acceptable? Meanwhile, while you answer, I will slurp a mouthful of tea. Better? Acceptable? Far better? Okay, let's roll with that. Getting better. Okay, so I'll talk for a little bit longer, and if it becomes unbearable, then you guys can. Okay, the stream is kind of quiet overall. Yeah, cool. All right. It's kind of hard because I have the volume of the stream bumped up, as far as I can tell, as high as it can go. And if I add gain, it for some reason starts to add distortion. So what I'm going to do is I'm going to turn the volume down a little bit on the desktop audio again, and if you guys can just bump their volume up in general, then that'd be great. So greetings and cheers to all you tea drinking hackers and coffee drinking hackers. First stream in quite some time. I can't remember the last one we did. I think we did one of those Pico CTF challenges last. But today we're going to be taking a different view on the security side. And today I'm going to be walking through the extreme basics of getting some kind of DNS exfiltration stuff happening. Now, the reason why this is, this is something that I've wanted to do for quite a long time, but it became a hot topic for me over the last 4 weeks while working on a particular gig, tax simulation gig with some people. And the DNS is what kept us alive long term. So what I'm going to do here is cover off basically from almost zero to something that functions and that will allow you to do really basic CNC and to do some very trivial file-based exfiltration. So the aim will be to be able to just execute some simple commands and get the results, and to be able to say, you know what, there's a 50 gig file over there and I want that pumped out through DNS as well. Okay, so that's effectively where we're going to go. It's going to take a little bit of time to cover it all. So we'll start off with something simple like the command-based CNC, and depending on how long that takes, we might stop there and maybe do a second session to cover off the file-based exfiltration. As always, sing out if you have any questions as we go, or if things don't make sense, I'll do my best to explain them a little bit more. So what I'm going to show you is just enough wiring to get you going so that you understand how things might work or how you might want to build your own tool. This isn't intended to be a demonstration of how you would build a production DNS-based exfil or CNC tool, because there's a lot of moving parts, and if you care about the security of your client, then what I'm about to show is not fitting, because we're not going to be doing anything like encryption or any packet validation or anything like that. We're literally going to be pushing and pulling data back and forth across a DNS channel, and that's it. So from here, if you can take this idea, you can build on top of it, and you can sort of whack your own protocol in over the top. So I'm hoping that I'll at least give you the building blocks to go away and do something fun. Okay, so as always, shout out to Guy Barone, the legendary musician who I seem to very much enjoy listening to at the moment. He's providing, with permission, the backing track to this stream. So hopefully YouTube won't jump on my back and try and prolong the content and say that I'm breaking copyright, because I do have permission. So yeah, if you don't listen to this guy, I highly recommend it. All right, so how many people we've got? We've got nearly 40 people tuned in, which is exciting. Okay, now before we get started, do you have any questions? Or shall I literally just dive straight in? No, coding go. T. There we go. All right, I will assume that there are no questions. I've got my bells working properly, so if you do have any questions, be sure to mention either the cloning or OJ, and I will see it light up red, and I will do my best to answer your questions. All right, so here's the go. When we're dealing with working on a client gig, there are times where we can basically pull out a reverse TCP style CNC using Meterpreter if we want to, or something even more trivial than that. There are times where that won't work and we have to resort to HTTP or HTTPS. We might need to pivot through proxies and things like that. But in some cases, when people really do have their stuff locked down and it's very difficult to get an advanced channel out, we're sort of stuck with other options when it comes to transports. And those tend to be the likes of DNS or ICMP or NTP or some of the lesser known protocols. They're a bit more painful because they're stateless, they're connectionless, they're kind of unreliable, those kinds of things. DNS for me is the preferred out of all of those options because there is a bit of infrastructure surrounding it. There is a bit of a guarantee that you're going to get results in certain scenarios. And so for me, I think it's a good way of sort of stepping away from the persistent or even stateless TCP transports and getting out into UDP land and still being able to do some kind of back and forth over those channels. And they tend to be a little more covert. Most companies don't really monitor their DNS traffic, so you've got a much better chance of getting your data in and out. The problem that you've got when it comes to DNS is that there's not really a lot of space in which you can play. So like if we have a look at the documentation, I haven't actually read this Wikipedia article, but what I'm trying to find out straight up is that there's a limit to the amount of data that you can send back and forth when making requests and responding to requests. Now, in the case of DNS, if we're looking to create some kind of C2 channel, we need a client and we need a server. So we need a custom DNS server that's going to handle the request that's coming out of the client, and that DNS server will take those requests, parse them, do whatever it is that it needs to do with them, form some kind of meaningful response, and send that back to the client. And the client needs to be able to look at that response and say, yep, okay, I know how to handle that. That worked or that didn't work. So that means that something custom has to be running at either end. Now, in the case of the server, if the organization that you're attacking allows sort of outbound UDP on any port, then you can configure your client to talk directly to your DNS server. But in many cases, organizations don't let you just do straight outbound port 53 UDP and talk to any arbitrary DNS server. They tend to lock them down to their own internal resolvers. So you're going to have to handle the case where you can pivot out through default resolvers. Now, if there are resolvers in the way, then you're going to have like DNS glue records and have your server out somewhere that's tied to a known domain name. And that sort of adds some other sort of bits and pieces that are a little bit tricky. So for the sake of tonight's discussion, I'm going to pretend that I don't have to go through a default resolver, at least to begin with. And from there, we're going to use whatever room we've got available in our DNS requests to have our sort of protocol baked in. Now, for outbound requests, when you make a request, you tend to say, I want to get an IP address for a particular domain name. That could be IPv4, it could be IPv6. You might want to look for CNAME records. For these kinds of transports, it makes the most sense, where possible, to utilize requests that are going to give you arbitrary data back. And the two targets for those tend to be service and text-based records. We're going to use text records we're just going to drop basically text-based payloads in the responses. So the aim here will be to have a client that generates text-based queries with data inside the URI, sorry, not the URL or the domain name. And then when that request goes out to our server, we're going to have the server pull apart that request, figure out what it means, generate a response, and send that back to the client. Okay, so what we're going to do is we're going to start off with something that I quickly threw together earlier on, which is just the basic building blocks of a server in Go. Now, I'm going to use Go for this for a couple of reasons, but the primary one is that this will cross-compile to any platform. It's a native binary that will run on any platform. You can cross-compile it for Linux on Mac or Mac on Linux or whatever it happens to be. But the kicker is it's a single source base, and you can target that platform to whatever else it is you like. I tend to use Linux. So the stuff that I've used in my gigs, I've had a custom Go-based DNS server. And there are elements of what we're going to do tonight that I've used in mine, and there are elements I've used in mine that you won't be seeing here, because I'm not going to give everything away. Go is not really sexy, but it's pretty good. So let me just walk you through the basics of what I've got here, right? Let's go to the top of the file. Now, right at the very top, I have this type called a DNS server. It's probably obvious what that is intended to be. And inside that type, we have a reference to a set of state. Now, that state will probably expand over time, but for now, all it's got is one string parameter that says, what am I listening on? So it's going to be effectively a bind address. Now, when I'm running my stuff in production, for want of a better expression, I bind to a non-privileged port and I port forward from 53 to my non-privileged port, because then I know that my code isn't running as root. I'm pretty certain that I write shitty code, and I don't want my shitty code running with root privileges on any box. And so that's why I do it this way. So the aim here is to be able to specify a bind address that you can configure, and from there it's sort of up to you to either run stuff as root or do the port forwarding thing like I do. Okay, so that's what those two types are for. Now, inside main, all I've done here is I've created a hard-coded instance, of the DNS server along with the associated state, and you can see that I'm hard-coding it right now to say listen to on all interfaces. Sorry, on 0000 port 5553, and that's what we're just going to use for testing purposes. Now, ideally, what you would do in production, you would have this passed into some kind of command line parameter, etc. So that's basically the go. We've got a bit of chat going on. What do we got? The Wizzy, doesn't Meterpreter run as root? Actually, no. Meterpreter is something that runs on the client. So the victim that you've popped is where Meterpreter is running. So that will either run as root in Linux if you're lucky enough, anti-authority system, or a user context. Now, if you're talking about Metasploit, that's a different kettle of fish. In Metasploit land, Metasploit runs as root if you run it as root. So I don't run it as root. I never run Metasploit as root. I always run it in a user context, and I have port forward set up, or I sit it behind Nginx or something like that. So as far as I'm concerned, my attack tools do not run as root. That's something that I'm hoping to help fix with Empire, because running Empire without root privileges is an absolute pain in the ass. I love the Empire guys, and that's not me having a go at them, but it would be really nice to get a few bits and pieces into Empire so that we don't have to run that thing as root either. So that's coming. I will be putting my money where my mouth is and helping out, so I'm not bitching for the sake of bitching at all. And I'm not going to be a student where I point out problems without offering solutions. I will certainly be helping out where I can. Plus, I've got some proxy stuff to throw in for Empire as well. So, OJ, what do you think of Go and memory safety? That's a very broad question, but I think for the most part, if you're going to write something like this, you'd be stupid to do it in something that isn't at least out of the box memory safe. I don't know really enough about Go and the way that it does its memory management to be able to say, oh, this is a fantastic solution compared to others. I mean, if I really cared about memory safety, I'd probably look at things like Rust. Plus, I am a bit of a functional programming nerd, so I think I would lean in that direction. But again, it's horses for courses. I've got more chance of getting people to understand what's going on if I use Go as compared to something else, particularly in the context of a live stream like this. Although, Justin, I'm sure that had nothing to do with your question. But yeah, look, I think it makes a lot more sense to do it in a language like Go. I certainly wouldn't want to do something like this in C. Okay, so all I'm doing here is I'm creating my state, and then I'm just putting a debug message saying this is the interface. This is the IP address and port that we're listening on. Now, you'll notice that straight away I'm creating an instance of a server using this DNS.server type. Now, where does that come from? It comes from this up here, this GitHub location, which has a pretty popular, from what I can tell, Go-based DNS server. It's quite feature-rich. I would recommend going to the GitHub repo and having a nose around the code and trying to understand it a little bit more. I'm deliberately using this to abstract the DNS stuff away a little more because we can get bogged down in all of the detail of DNS, or we can build something that utilizes DNS that's useful to us. So that's what we're going to do instead. Okay, so as I said, we create an instance of this server, and then what we do is we say, I want to defer a call to shutdown on this server type to the end of this function. So that means that when function main exits, or just before it exits, it's going to call server.shutdown for us. That's just a classic sort of Go-based approach to making sure that you tidy up your resources. And then the next line basically says, I want that server to go away and do both listening and serving of DNS-based requests. That's what that function call does. Now you'll notice at the end of this line here on line 85, we're specifying a handler. And the handler that I am giving it is the reference to this DNS server. So basically what this means is that my DNS server type has to implement one function that knows how to handle DNS queries. So if you look up here on line 51, this is the function that needs to be defined. Okay, it needs to be called serve DNS, and it takes two parameters, one being a DNS response writer and the other one being a request message. Okay, so if you define a function that looks like this on your own type, you can pass that in as a custom DNS server handler for when DNS requests come in. More discussion. Hey guys, quick question. Hopefully someone knows the answer. I wonder why I'm a Blu-ray. Oh, jeez. Okay, I'm just going to ignore that and I'll let you carry on. Okay, so the pattern when it comes to handling DNS requests using this DNS server is, first of all, you've got to create a DNS message that you are going to use as a reply to the request that's come in. Okay, and so these two lines are effectively me saying, I'm creating an instance of a message response, reply, and I'm setting the reply based on the response. Okay, so the request. So the request has come in with saying this is what I'm replying to. These two things here are just hard-coded values for me. At the moment, what I'm going to do is I'm going to make it so that if this DNS server gets a request for an A or an AAAA record, then the values that are going to be sent back are localhost, both IPv4 and IPv6. Okay. Now, when a DNS request comes in, it can actually have multiple questions or requests in it. And so, as you can see on line 59 here, .question is actually a list of questions, and that includes all the different potential types like type A and type AA, CNAMEs, blah, blah, blah. So what you should be doing here is iterating over those questions and then looking at the question type. So you can see that's what we're doing. We iterate over the question and then we have a look at the type of the question that we're currently looking at. So I've just got a few cases here, type A, type AA, type any. And all I'm doing so far is I'm saying, right, when I receive an A request, I'm just going to give it my pretend IPv4 address. And I'm going to return a result that has a TTL of 30 seconds. Now I'm going to come back to TTLs later on. For those who don't know, TTL is the time to live, and that tells the client how long the answer is valid for. Now this is actually a really important thing for us when it comes to doing DNS-based communications, because if the DNS server or client that is talking to us caches these responses anywhere along the way, then that's actually going to get in the way of repeated requests. There are other ways around that too, which we'll discuss as we go. But it's important to be aware that if you send a very large TTL, then you're going to have to sit back and wait for your client or server DNS cache to flush out before it's happy to make that request for you again. Okay, so same story with the IPv6 record. If they come in and say any, we'll give them both. And if it's text, I'm just going to hard code a result saying hi guys. Now you'll notice each one of these is calling append result. Now that's a helper function that I've written, and I do use this myself in my other code base. And what this does, it basically says, here's the data I want to attach to the response. Can you please go and wire in all the bits and pieces that go with it? So basically what you need to do is you need to create a response header, and that includes details of the request that came in, the kind of request that came in, and how long you want that response to live for, so that it can associate the request with the response and it knows how long that lasts. Now you'll see here that I've just got a bunch of checks to say, okay, well, if it's an A request, then wire in A request header related bits. Same with AAA, CNAMEs, NS, etc. So that's all pretty boring stuff. Nothing too special going on there. This bit's interesting because when you return results via DNS, there are two different ways that you can do it. And depending on the type of request, you should add responses to either the answer section or the extra section. Okay. So as you can see, this helper function here is pretty bog standard. There's not really anything special about it, but later on, if you want to understand more about why this is the case, I recommend going and reading the documentation. But suffice this to say, for our needs, I just wanted a helper function to say, can you please take this response to this request and wire it in, and off you go. And that's exactly what it does. And then when that's called, then the message that we've given it to add the data to will now contain the response. So after all of these append results, you'll see here we've got w.writeMessageM. So that's us saying to the response writer, hey, here is our DNS response message. Can you please send it back down the wire? Okay. Hey, Peleus. So what I'm going to do here is I'm just going to run this server, hard coded as is, and you can see what it's going to do. It just basically says we're listening now on port 5553. Okay. Now, to demonstrate that this is doing the kind of thing that I would expect it to do, what I'm going to do is I'm going to run NSLOOKUP. I'm going to say run on a query on port 5553 and do a query of type A, and I'm going to ask for google.com. I want to know the address of google.com, but the server that I'm talking to is localhost. So that's the syntax for NSLOOKUP, saying I want to talk on a different port, I want to do an A record for a particular address, and I want my custom DNS server to run. So when I hit enter here, according to my local DNS server, google.com is 127.0.0.1. Now if we go back up here to where the DNS server is running, you can see, just like what we have over here on the right and on line 63, line 62, we've got a printf saying, oh, we've had an A request come in for google.com. Okay, which is exactly what we would expect. So we can change this to be any kind of record we want. So here we go. If we query for IPv6, we get loop back on IPv6. So that's doing what we would expect. I haven't tested any on here actually. Let's see what any does. We should get a couple. There you go. So we've got localhost on IPv4 and we've got localhost on IPv6 as well. So that's also behaving as expected. Now, this is the thing that we actually care about for the sake of this demo. Is if we ask for a text record, it should come back and give us Hi guys. So this is where we're going to start adding data. Now, there are size limitations on the amount of data that we can return. So we have to kind of work within those constraints. If we're doing outbound commands, for the most part, they can be pretty small, not too much of a concern. But for inbound, we don't have this facility anyway. We have to encode things as part of our URI. Okay, any questions so far? Does that make sense? We can see that we've got our very basic DNS-based types here. We've got our server. Nothing really special going on here, right? So what we're going to do now is we need to come up with a way. We need to figure out a way of saying, okay, if I had some kind of client running on a victim's machine, how could I talk to a server in a meaningful way? So to begin with, we need to come up with some kind of protocol that's going to allow that to happen. We need to be able to say, right, if I'm encoding certain data within a certain URI, then what would that look like, and how would I know? So there are a number of different ways that you can do this, and it's all completely up to you. Some people I have seen have a custom protocol that's effectively base64 encoded, or URI encoded, to work with DNS and split across the 250 or so characters that you're allowed to specify in a DNS request, and that's sent down the wire, and then the DNS server has to effectively reassemble that at the other end. To begin with, for our really basic CNC, we're not really going to do anything like that. What we're going to do is we're going to do something even more simple than that. So I'm going to say that our DNS server is going to run on a host that has a particular DNS suffix. So pretend that it's actually a real URL. And inside subsections of the URL, we're going to have something that says, I'm actually making a request to see if you've got any commands for me. Okay, so for example, if we installed this thing on a machine, and that machine was called, I don't know, let's call it, and I pick a theme. Let's have a theme. Someone trolling me. DNSSec. I don't think so. All right, what I'm going to do is I'm going to have a machine called Jardeth. Okay, so if I was to make a request, what I might do is have a request that's very similar to this, and I might say, you know what, I want to know Jardeth's current command that you want me to execute, right? So I might say Jardeth dot whatever dot domain name. So let's say we had a domain name of, I don't know, let's call it a.ly. Okay, so we own the domain name a.ly, and we're going to make a request for jardeth.a.ly. Okay, now I'm pointing that directly at my local host, so we should see here that jardeth.a.ly is the request that's come in. So what I might think is, okay, so if anything comes in with a something.a.ly, I might say that something is the machine name of the thing that the client is working on. So I've owned Jardeth, a machine inside an organization called Jardeth, and Jardeth is now running this little client of mine, which periodically pings out and goes, hey, I need to run a command. Can you give me that command? Okay, so we need to be able to say, right, for Jardeth, I want to be able to run this command. Okay, now in order to be able to do that, there's a few things we're going to have to do. We could perhaps drop commands on the file system. We might say, okay, I'm going to drop a file on disk that says, if Jardeth calls me back, then I want this command to be executed. Right? We might want to have something a little bit more interactive as far as the server is concerned. So we could actually type. We could say, hey, you know, I want set Jardeth whatever, and behind the scenes there is some kind of dictionary that says, hey, when Jardeth calls in, then that's effectively what we're looking to respond to, and this is what we're going to send back so that they can execute. All right, starting to warm up. That cup of tea is finally doing its job. It's pretty cold in here. All right, so any questions so far? Am I failing to explain myself? So Rubus is about to get kicked because he keeps saying get system. He won't even bite. Yeah, I just bit Will. I know I'm stupid. All right, so what I'm going to do is I'm going to add some more stuff to our state. Okay, so what I'm going to do is I'm going to have a base domain, which is a string, and that's going to be the a.ly, right? So that a.ly is effectively the domain name that we could technically bind out on the internet. Okay, that's the thing that we've bought, we've registered, and whether we use it locally or not is not the point. The point is that this would facilitate us to be able to use a.ly in the open internet and allow default resolvers inside organizations to reach out and talk to us, because that base domain is always going to need to be there. So we're going to have a base domain, and we're going to utilize that as a starting point for our DNS-based code. Which means I now need to add it in here. So let's go, domain is going to be a.ly. Okay, let's just make this a little more pretty to look at. Why does that always happen? Oh yeah, I know. I've got to, even though there's nothing after it, I've got to put another comma. Okay, so actually let's do the proper nested thing and do that instead. Okay, so now we're just saying we're going to listen on that address, and that's the base domain that we're going to be using. Now I'm actually making this part of the state because I want all of the functionality that comes with the DNS server to have access to that state. Okay. Now I'm going to basically ignore all of these things here. Okay, all of the magic from here on in is going to happen inside this text record handler. All right. Now for me, if something queries my DNS server and it doesn't conform to what I'm expecting, then I'm basically going to ignore it, or I'm just going to return something hard-coded. So ignoring all the other types of requests, what I'm really interested in seeing is the domain name that we have the one that's actively being queried, and if not, we're just going to return nothing. Okay, so this is where my playing with Go is going to start to look very messy, because a lot of this stuff I can't remember off the top of my head. But I have various references here, and we'll work through them as we go. And if anyone here knows stuff that I don't, then be sure to let me know. All right, so the first thing I want to do is, does the tail end of this domain actually match what we were expecting? Okay, so you'll notice that as part of this output here, all of the requests end with an extra dot, right? This extra dot here. So rather than cater for that in code, I'm actually going to shove the dot at the end of the domain there. And so what I'm going to do here is I'm going to say, if, I think it's strings.end with, and I can give it q.name, which is the request, and then is.state.domain, so that's the domain that I am currently handling, then we're going to append that result. Otherwise, I'm just going to go, nope. Now, let's have a look. Strings. Got to add it to our import section. And I'm pretty sure that that is not correct. Anyway, so let's go and have a look at Golang strings and with, I can never remember this stuff. Suffix, has suffix. So where did I get end with? It's probably from Ruby or some other shitty language like that. Strings dot has suffix. There we go. All right, so let's run this again. let's do our NS record here, and we'll do jardef.foo.com. All right, and see how it's come back with nope. But if we do jardef.a.ly, we get a hi guys. Okay, so we have the ability to say, are you ending with the domain that we would expect? Now, those people who are true hackers are probably looking at this going, but there should be an extra dot in here because there might be a, leethacker.ly, and that would also respond. So we should technically have a dot in front of it. Okay, so we have the ability now to make sure that we're only going to be responding to the domain that we're currently handling. Right now, as I've mentioned before, these parameters here would be command line based or put in a config file. I'm just going to hard code them here because I can't be bothered doing all of the config based parsing. That's not really something that's within the context of this stream, so you guys can go and figure that out by yourselves. But what you would actually have as well are two different values for TTLs. So first of all, you would have a default TTL, which is it's going to be a uint, and you'd also have a timed. So the default TTL says, this is the TTL I'm going to return for any requests that I don't care about or aren't part of my protocol because I want to look legit. But everything else, like a result of a function call or a command or something like that, everything else I want a really low TTL so that future requests are actually going to succeed. So I'm going to call this result TTL. Okay, so we've got default TTL and result TTL, and I'm going to wire those in down here. Okay, so by default, your default TTL is probably going to be something like, so what's the default? I think it's 10800 when I see that by default in the likes of Gandhi, for example. I see 10800. And what is that? That's in seconds, so it's probably something like 3 hours, maybe even longer. Yeah, it's 3 hours. So that's 3 hours. Whereas our result TTL, we actually want that to be really, really low. Something like 30 seconds or 10 seconds or 5 seconds. I'm going to set it to 5 seconds. Actually, no, I'll set it to 3 seconds just for the sake of this exercise. So instead of 30 seconds in all of these, so for all of the A whatever records, I'm going to go is.state.default TTL. Okay, so that basically says don't come back to me again for another 3 hours. Okay, bugger off, leave me alone. If they come back and they do the same thing with a domain we don't care about, we're going to give them the default TTL. However, if it's valid, if it's something that we're looking to handle, we'll use the result TTL, which will be just a few seconds. Okay, so that means if we come back here and we say jardef.derp.com, we get nope, and you'll see here we've got new text request for jardef.derp.com. Now put a new line there. If I come and do that exact same thing again, hopefully, it did actually request it. Now the reason why that actually happened is because we're going direct to our DNS server. If we had, some kind of default resolver in place, that result would be cached and we wouldn't actually see another hit on the server. But behind the scenes, you should be doing stuff like this to try and make your DNS server look a little bit more legit. Okay, again, let's just make sure we haven't busted anything. A.ly. Okay, and you'll see that the TTL, I don't know how to use dig. I was going to say let's actually have a look at the TTLs, but I can't remember the way of getting that stuff to cough up, so I won't bother. Anyway, so we have our listen address, our domain, our default TTL, our result TTL. Now, if we were going to find a way of segregating these things a little bit more, we might say, okay, for me to know that a machine is coming out and requesting a command, I need an interface to say, hey, that's a thing. Someone's made a request to me and I didn't have anything to give back. what I want to do, given that this is actually going to be our command channel, I'm going to start returning empty responses, and our client will basically do nothing if the response is empty. So we know for sure that our request is going to come in and it has the domain suffix that we're looking for. What we might need to do is segregate it further to be able to say, I don't know, instead of jardeth.a.ly, we might need to chuck in another letter, like C for command, for example. Okay, so that means we're saying machine jardeth is requesting a command. And then maybe later on, if there was some other thing that we wanted it to do, like jardeth might be looking to create a file on the server or something similar. That's effectively a little way of baking a mini protocol into your domain name. For now, I'm going to ignore doing more. I'm literally just going to take whatever is before our current domain, and we're just going to use that as an identifier for now. And we'll get into a more complicated protocol a little bit later on. What's going on in chat? Nothing interesting. Okay, I'll move on then. Does anybody have any questions? I'm guessing not. Either that or you're not paying attention, which is also fine. So what I'm going to do now is I'm just effectively going to strip off the tail end, so that we know the exact name of the machine that's making the request. Okay, so what I want to do is strip off the bottom end of the string. So that would be something like, how do we slice strings? Anyone remember? It'd be something like we would take whatever the question name is, and we would slice it by doing something like going from 0 through to q.name.length minus is.state.domain.length, or something similar to that, right? So that's how you would do it. We'll just say that that's the machine. Now that is not going to work because the syntax doesn't make any sense. We might even need to do, is it len? There you go. So that would be len, oops. The len of that minus the len of, I can't type tonight. So machine is declared, and okay, that looks like it's going to work. New text request for that. So here we're going to go format.printf machine name is, and we'll just output that straight out so that we know. Machine name is machine. Does OJ run Hackers Helping Hackers? No, I don't, but have in the past submitted winnings to Hackers Helping Hackers, because we're all about hackers helping hackers here, aren't we? Actually, helping hackers. All right, so what happens when I do this? We get machine name is Jardeth. Okay, so now we know we've taken off the tail end of that, and we've actually got a machine called Jardeth. Now, what I'm going to do is I'm going to add something to our server state, and the server state is going to contain a map of strings to strings. We're going to call that commands, right? So how do we define a map of string to string? It's something like that, isn't it? Is it, do I type, I think it's map. Let me quickly check the syntax of this. I know I've got it stashed somewhere. I've got it, trust me, I know. github.com OJ GoBuster. I know it's in here because I use a map somewhere in GoBuster. So let's just have a look. Map int bool. Okay. So that, oh, it was right. Ha! What a fool. Okay, so the command is basically going to be a lookup that says, for this machine, what command is currently applicable. and we're going to need to be able to modify these commands on the fly. Although to begin with, I'm just going to I'm going to hard code a command. Okay, so commands will be a make map string. I think that's okay. And then before we kick off our server, what I'm going to do is I'm going to go is.state.commands. Now, how do I add a command? I think we'll go back to GoBuster for that, because I know that I do it somewhere in here, right? String set. Add. Add range. Okay, so all I have to do is literally set it directly. Commands jar def equals I don't know. Let's just go with ID. Okay, because that's technically the string of the command that I want executed. All right. So what I need to do now is check to see whether or not the machine name is in the map, which again I've got listed here somewhere. Contains. There you go. And if that's not found, then we're good. Okay. So I should be able to go like this. Value and found equals is.state.commands machine. We can say if found, then do something. Otherwise, we're just going to return an empty string. Here we're going to, oops. We're going to return val. Okay. So what I'm saying is we're going to reach into our commands dictionary, and if we find a result, then we're actually going to take the value that we've pulled out and we're going to poke it in. We're going to poke it into the result that comes back out. Now at this point, we are going to have to remove, because we've actually returned the command. Technically what we would want to do is remove it, but we'll come back later on. When we get to the interactive point, we want to be able to set a command in our console, and then when it's actually executed by the machine, excuse me, when it's executed by the machine, we want to remove it from our commands list effectively. So that's what we'll do. But for now, I'm just going to leave it as hard-coded, right? Okay, so if we come in here and we go, right, give me the command for jardef, we should, there you go, it's come back with the text of ID. If we ask for the command of, I don't know, bool, that should come back blank. Okay, so now we've got the ability to at least store some kind of state with our DNS server, okay? Now we actually want to make this a little more interactive, yeah? So what I'm going to do is we want to have two threads of things going at the same time. We want to be able to do listen and serve for our what's it called? For our DNS server. We also want to have some kind of interactive console menu that is allowing us to on the fly configure stuff. Okay. So in order to do that, what we need to do is kick off a Go routine. So it'd be something like, what does this look like? See how hopeless I am at this language? Where is it? I've got it documented here somewhere. Come on. Show me the error of my ways. I should show you guys at the same time, right? Okay, here we go, go funk. That's what I needed right there. All right. So go funk. So this is what we'll be doing. And off to the side, what I'm going to do is just going to say, we'll go console handler. And we're going to have pass in the state because we're going to need to use that. Actually, let's do it the other way around. is.console handler, right? Because then we can make the DNS server itself sort of contain the functionality that's related to it. Okay. Console handler. Okay. Whoops, what did I do? Where is my error? Function must be invoked in a go statement. I thought I did. What have I done wrong? Go. Oh yeah, I gotta do that. Easy. I wonder if I can actually do go is.console handler instead. Yeah, of course I can. There we go. So I don't even need go func. I'm just going to say kick that off on a go routine all by itself. And what I'm going to do here is I'm going to say while true. Oh no, there is no while true. I've just got to go for. I think that's how we do an infinite loop. Now, while this is running, what we're going to do is we're going to display menu. Oops, I can't type. So we won't even, yeah, we'll just display the menu and then we'll say we want to actually read in some console input as we go. Let's quickly do a very simple menu, display menu. So we're going to go format.printf, or we'll just go print line actually. So what are we going to do? What are we going to do? We probably don't even need to loop over a menu, do we? So instead of displaying, actually let's just comment that out for now. What we'll do is we'll say format.printf. We'll just give them a console, something like this, right? So we're going to print just what looks to be a console there, and people are going to be able to type. Now, I've never read stuff in from standard in before. So golang read from standard in. How to read input from the console. All right, what do we do? Oh, there you go. We've just got scans and things like that by the looks of it. Not sure what's going wrong with the block. So, okay, so there's attempts have ended with the program exiting before I'm prompted for input. I'm looking for equivalent of console to read line. So you've actually got to create what looks to be a reader. And you can read string up to and including new lines. That doesn't sound too bad, does it? All right, let's create one of these then. We will drop that in here, which means we're going to look. It looks like we're going to need buff.io and OS. So buff.io OS. It will complain that I've created it but not used it. Okay, so now what I want to do is say input equals reader dot, what was it? Read string. Up to a new line. I assume that's what that's talking about. So, and then what we'll do is we'll go format.printf. The input was, just so that we know what we're doing. Input, and straight away I'm going to break out of the loop so we don't end up in something infinite. Assuming. Where are we? Cannot use type string as type byte. Oh, okay, so I've done something silly. Single character, apparently. Is that right? Multiple value read string in single value context. Right, so that's probably because there could be an error in the process. Yes, error declared but not used. So if there is no error, then print out the input. Okay. Oh, it's GoBuster. He's using it as a syntax reference. Yes. Yes, that's right. Thank you. All right, see you soon, Justin. Yeah, I was using my previous messy GoBuster source code to write more messy Go source code for DNS related shenanigans. KiwiCon hoodie has done its job. Kept me warm. All right, okay, let's run this and we'll see what it does. So, DNS. Hi. Ooh. Nothing's happening. Why is nothing happening? I wonder if it's expecting, say, for example, a carriage return. But let's just quickly test to see what's going on. Print line scanner.text. What is that? That must do the entire standard in. I kind of like the idea of the scan line input, but again, buffering it kind of sounds like the right thing to do. With the next block, you need to point to the variables you're assigning input to replacing. Blah, blah, I don't want to use. You want to do something like replace it. Yeah, I suppose we could do that. We could do that, couldn't we? Read string. Let's oh, hang on. If error equals nil. There you go. The input was. So, clearly, I had no idea what I was doing. What's going on here? OJ is only displaying the output if input isn't nil. Yeah, exactly. Thanks, Minstrel. Yep, string. No, you beat me to it for some reason. I hadn't picked up on it, but thank you for that. So yeah, if there is no error, then we'll print out the input. So basically the Go at this point is we have the ability to read data in. We know that we're going to have a new line at the end. So what I'm going to do is I'm going to rip the end off. I'm going to go input equals input. Go from 0 to the length of input minus 1. Actually, no, there's a strip function, isn't there? Is there a there's a Golang strip, someone? Got it dotted somewhere. Where is it? Got it somewhere. Sorry, I'm just looking through some other notes that I've got. Don't think that I'm being shady or anything like that. Trim space. Trim space is the thing that I'm looking for. So we can go input equals strings.trim space input. So that should give us the content without the new lines. There we go. The input was FTK. All right, so at that point, basically what I want to be able to do is say we're going to have a very simple command style interface. So we'll have a single word command followed by a set of parameters that go with that command, right? So we might have a set command for setting the command on a particular machine. Okay, so I'm going to get rid of this display menu junk, and I'm going to get rid of that, and basically what I'm going to do is I'm going to do this. We're going to split the strings based on spaces. All right, so I'm pretty sure that I can do we won't call this input now, we'll be calling these, we'll call this words. Words is strings.trim space, but we're also going to do strings.split. Now, I'm pretty sure split is what I'm looking to do. Again, I might just see if there is off screen. I'm pretty sure I had that here before. Where is it? Has suffix to, where are you, replace, contains. I've got a lot of messy stuff stashed everywhere, effectively. I can't see it in there. So Golang string split. There you go. That's it right there. So I can give it a split and just tell it what I want to separate that on. So it is split followed by a space. So split anything based on spaces, and we'll just bubble that down to some kind of handler. Okay, so I'm going to assume that someone's going to type something in. Technically what I should be doing is checking the length of words and blah blah blah, but if they don't give me anything meaningful, then they can get stuffed. So what we'll do is we'll go if words 0, although I suppose, can we do case? Sorry, switch word 0. If we go case set command, does that check out? It does. Okay, so I can match directly on that. So let's say we've got a set command. Actually, let's get rid of the word set. We'll just go command. What we'll do here is we'll go is.set command, and we'll pass in a slice of the words up to and including length of words -1. I think that's what we did before, isn't it? Yeah, okay. I might not even need to put that second part of the slice in. Okay, so set command, and we're going to be getting a list of arguments, which is an array of strings. So that should be good. Okay. Let's see if this works. I do this. Yes, I can. Okay, so I'm skipping the first argument because we know it's CMD. Here we know that the first of the arguments is going to be the machine name. So the machine is going to be args0. And then the rest of the command that we're passing in is going to have to be all of the other arguments that we were given joined together. So I would assume we've got something like strings.join, which is the opposite of splitting. We're going to rejoin them with spaces. So may strings.join args1. So everything after the first argument, rejoin them with a space. Let's see if that works. Machine declared not used. Yep, we know that. Command declared not used. Okay, that seems to have checked out. So at this point, what we want to do is go is.state.commands machine equals command format.printf command for set to blah. Now let's print these things out so that we're sure. So command for whatever the machine set to command. All right. What does this do then? DNS. So command for jar death is ID. There you go. Command for jar death set to ID. I keep missing new lines. Okay, I hate missing new lines. It's ugly as sin. Right, so with that in mind, I should be able to get rid of this hard-coded jar death line here, and we should be able to start interacting with the DNS server a little more. So let's go. What was it? CMD jar death who is. Command for jar death set to who is. So now if I go here and do jar death, we get who is. If we, whoops, what am I doing? If I do command jar death ID, we get ID. some reason my DNS output is not behaving itself. Oh, it's probably because the requests are coming in and it's being gobbled up or something by the requests that are coming in from DNS and me spitting stuff out asynchronously. I should probably handle printing out in a much nicer fashion. In fact, I will do that in just a minute. I'll show you how I would solve that problem. And so I should be able to go command bool is I don't know. Let's do something with spaces, shall we? Find root something called I'll go iname star zing star. So this is me saying I want to set that command to something that I may actually invoke in a Unix system. So if I now do bool, there you go, find. So we have the ability now to interactively set commands for whatever is requesting those commands from the client side. Have I missed anything? So this is the go at this point. Ugh, Justin, you're a shocker. Domino's Pizza, nothing special. Is there a way in Golang to check the .head element of a list? So DigiPsych, I assume that's how you want your name pronounced. Basically, there is no way of saying .head. You just have, your list is effectively just an array. So you would look at the length of the array to make sure it's non-zero, and then you would pull the first element out of the array, and that is effectively the same as head. If you go straight for index 0, you know that you're going to throw some kind of exception if the list length is not non-zero. I hope that answers your question. Okay, so we have the ability to set a command. What I should do here is we should check to see if we're saying quit, and if so, we can break out of our loop. I got to get rid of that line there, and there we go. You're welcome. You're absolutely welcome. Please sing out if you have any more questions, mate. Now, actually, what I need to do here is I need to find a way of killing off the server. Because when I type quit, I don't currently have the means to kill the server off. So I wonder how I would do that. Maybe what I should do, the server is the DNS server. Let's actually put inside the DNS server, we're going to have a server, which is a DNS.server. Is that even possible? Actually, we might make it a pointer to one. Yeah, that's possible. So then we should be able to go DNS.server. I might need to do the address of that. Is that how it works? DNS.server is not an expression. No, it's not. is.server is though. Okay. So is.server.shutdown. is.server listen and serve. Okay, so we have the ability now to whack the server in as part of the state. The server implementation itself. So maybe what we can do here is maybe we can go is.server.stop. Doesn't. DNS server has no field or method stop. Okay, so we're going to need to go and have a look at Golang DNS server shutdown. Maybe it's actually called shutdown or something similar to that. Ooh, look at that. Shutdown, not shutting down. And it's on the exact same DNS server that we're using. So maybe we can just jump straight back in here and call shutdown. Oh, hey, all right. Let's see if that works. So if I type quit, yeah, hey, we're done. Awesome. I don't know why we got another DNS prompt to pop out. That's a bit strange. CMD, whatever. Quit. Where's that extra DNS coming from? I would have thought that shutting down and calling break would have skipped it, but whatever. Anyway, we're not building a production app here. I want you guys to get familiar with the kind of approach that you might want to follow. Anyway, so as you can see, we've got a very simple menu-based infrastructure here that we can use, and from here we're going to start actually executing bits and pieces. Now, what I'm going to do is I'm going to show you how you can actually put something. For now, I'm going to just do this in Windows. Okay. This is the approach, or something very similar to what I did while I was poking a client recently. So I've got a Windows VM sitting here ready to go. And so what you can do is you can do something like, you can invoke PowerShell and say, so let's do this from within PowerShell. So if I run NS-lookup, I can set my query type to text. I'm going to do the same thing with port, even though I didn't need to do this on the target, 5553. I'm going to pretend I'm called jardeth, jardeth.a.ly. And the server should be 10.1.10.40. All right, so if I run that, what happens? Can I even get out? Request timed out. I should probably check what my IP address is. So I'm on the right network. Let me have a quick think as to why that might be the case. It's looking at the wrong. No, is it? Unknown server unknown. Anyone else want to help me here? NS-lookup. I would have thought the syntax is pretty much exactly the same. Oh, hang on. Is it running? Is that my problem? It's not running. What a muppet. Well, let's just make sure that this works. Need to put that port back in. Port equals 5553 10.1.10.40. Please work. Please work. DNS request timed out. So we're probably not even seeing that get through out here, right? Nope, we didn't see anything at all. Why is that? Is this Windows NS-lookup being a pain in the rear? Let's see. Usage. That's not particularly helpful given that it hasn't told me what the options are. Firewall on your DNS server. Well, Jared, if I had pondered that, but no, because I should be able to do that from pretty much anywhere. In fact, what I'm going to do is I'm going to do it on a different machine, which is on the same network. Let's just see if it works. I'm typing it into a Mac, which has exactly the same NS-lookup syntax. P.ly. Alright, so I just ran that on the Mac and hey, there you go. It did actually work from the Mac. So that should work from inside the virtual machine. I really don't know why that's the case. I'm wondering if it's got something to do with the port number. But then again, if I put, yeah, look, so clearly there's something up with this parameter, maybe -p, invalid option. Ah, now it tells me it's invalid. So yeah, I guess it was okay. I don't know why that's not getting out. That's very odd. Maybe it's got something to do with the fact that it is a virtual machine. Let me try it over here again. This time I'll do it on a Windows 7 VM on my laptop, and I'll see if that's actually able to get out all the way across the network. while that's running, if you guys want to ping me with any questions or concerns, I'd be more than happy to listen. So as you can see, like this is a pretty trivial setup, right? That very, very simple CNC is actually not that difficult to get running. Just do it on a no. Nice try. Alright, NS lookup. I'll use a different machine name this time. Port 5553 thing.a.ly 10.1.10.40 server unknown. Yeah, that's really interesting. For some reason, that isn't happening. I'm wondering if it has something to do with the order of parameters or something similar. What's going on there? Nope. So as you can tell, I mean, in this case, with when I was attacking these Windows machines, I just used the default resolver. Not sure unless the network on the VM isn't working. Can you reach the DNS server on any other port? That's a good question. I know that outbound DNS on that thing does actually work. I wonder if, let's see. Oops. Okay, so that's interesting because that basically ignored the port that I'd specified. Let's have a look. Let's go back to our web browser, which is number 4, isn't it? Windows NS lookup specified port. Right, so that should be it then. If I specify -port on the command line, you would port is right based on the Docker. Yeah, that's what it looks like, but it doesn't seem to be using it, does it? I don't think I've got nothing out here that says I can't, but it doesn't actually look like it's adhering to what I'm asking it to do. Whatevs. I'm not going to run it as root. Or should I, for the sake of this exercise? Actually, Wireshark. See, now that's just getting nerdy, isn't it? Don't ever do what I'm about to do. Just for the sake of a test. That's all I'm doing, right? Oh yeah. Okay, I'm gonna actually have to build it and then sudo the binary. Okay. Now if I get rid of the port, is it actually going to do something? Hey, okay, so it works. For some reason it's ignoring the port, or maybe something is actually blocking the outbound port. But the important thing here is that we've demonstrated that this is actually possible. And then when I go back out here, we can see machine name is Jada. All right. All good, all good, all good. So, am I in trouble now? Quickly writes down steps under heading of best practice. Please, no. Justin, so doing it on the command line, you don't get the /set option, right? I'm pretty sure that's not how it works. You have to go -port equals. I will humor you. Ooh. So go. I'm in the wrong one here, aren't I? This is what I want. Let's look up. Yeah, go run main.go. Can't do that because I'm bound to 5553. Okay. Yeah, so I mean, I don't know whether you would just put whack in front of that or not, but I'm pretty sure you don't. Let's just see. I'll see if Justin's smoking crack or not. Nah. Because I think the set command is done when you actually use interactive NSLOOKUP. So if we go set type equals text, set server equals 10.1.10.40. Is that what it is? Clearly not. But yeah. Okay, so whatever .a.ly, maybe I have to do it this way. Request timed out. I am running, right? Yeah, it's running. Server address. So yeah, for some reason, maybe there is a firewall based thing. In fact, I'm pretty sure I don't have the firewall turned on. Yeah, let's just turn it completely off and we'll see. I thought I'd had it completely turned off given this is just a dev box. No response from the server. Keep pressing my buttons wrong. That certainly came back a lot quicker though, didn't it? Yep, don't know what the go is. Anyway, right now it's not really relevant. Let's just move on. Okay, so we have the ability to set the command. I'm gonna from now on. I'm just gonna run. I am gonna run it locally under the context of sudo. Please don't abuse me. So effectively, what we want to be able to do is this. Do it from inside PowerShell again. We go NSLOOKUP. Query type is text. I'm not going to specify the port, obviously. Machine name jardef.a.ly, and the server is 10.1.10.40. So if I run that, we should get something back. Okay. Now, command jardef calc.exe. So if I run this again, we get calc.exe. Now from here, if I index into that, see how I get calc.exe as the exact string, and so I should literally be able to execute that. And the way we were doing this before is piping it to PowerShell again. So as you can see, we can actually pop calc in this way. So that means basically anything that I now set inside here, cmd.exe, cmd jardef cmd.exe. Let's go back here and do that again, and now we're in command prompt. So we have the ability now through our DNS server to effectively produce commands. Now, what you can do here, as you can see this query that I've got running, you can just whack this in a scheduled task. Effectively the equivalent of Windows cron, right? So you create a scheduled task that every 5 minutes invokes something like this, and you have the ability to remotely execute commands directly through DNS. And you configure it so that the machine that it's running on has its machine name encoded in some way in the DNS request, whether it's literally part of the domain name or whether it's encoded using some other scheme. That's completely up to you. But as you can see, we have the ability now to execute these commands arbitrarily. Now, I was using something very similar to this on the job that I was explaining earlier on. And thankfully, we were able to abuse this backdoor, despite the fact that it has limitations on the amount of data that you can send back and forth, to spin up Meterpreter and Empire sessions, which is very, very handy and is a really nice spot to just sort of have as a last resort in order to invoke commands. Very, very handy. Okay, let's have a look. What's being said? NS lookup, guys. Windows firewall allows any out. That's what I thought, Jadeth. Yeah, public network actually block it. Weirdness abounds. Yeah, exactly that. Win10 seems to have that outbound open. Yeah, a lot of machines have that open in Singularity. Okay, so yeah, PowerShell is a DNS route. Yeah, exactly. I kind of like that as well. I mean, at the end of the day, you don't even need to pipe that to PowerShell. You could do something completely different. But the beauty of doing it that way is, like, for example, you could probably change it so that instead of having this, you could say IEX. So IEX is invoke expression. So that means that we should be able to, oh man, I'm in the wrong window. We should be able to go back here and we can go command Jadeth and actually put some PowerShell in here. So what's a good idea of some PowerShell to do? I don't know, let's go get item C. I think get item C is valid PowerShell. I'm not a particularly big PowerShell guru either, but if we do that, oh, backslashes always kill me. Maybe I can just go cmd Jadeth. Let's get some valid PowerShell that's going to spit something out. ls. So if we do ls and we do IEX NS lookup, we get our so what we need to be able to do is take that maybe and pipe it to IEX. No? What am I doing wrong? I wonder if I set that to something. Oops. Okay, X is ls. Ah, it's because it's in quotes, right? So if we IEX X, that's just evaluating the string. Yeah, so you could probably do something like do that and pipe it IEX. There you go. How filthy is that? Anyway, point is that you can change your backdoor so that this will actually run PowerShell directly, which isn't particularly bad. That at least gives you the idea of the kind of thing that you can do. Okay, so with that in mind, let's have a look. Well, how are we doing for time? Is everyone clear on the approach that we've taken so far? Like, there's nothing here that's particularly amazing or difficult, but the kicker here is being able to go, okay, once we've done something with it, once we've executed a command, how do we get the result? So what do we got here? PowerShell. Were you just using the DNS to send commands or also for pulling stuff out? Right, Jadeth. So I had two things going on. I had the same custom DNS server doing multiple things. So my custom DNS server is a file-based exfiltration tool, a very small CNC, and also a very weak backdoor in the way that you've just seen. So I was using it to invoke certain commands blind. I was using it to invoke certain commands non-blind, and I was using it to exfiltrate large files over DNS as well. So behind the scenes, the PowerShell thing that you saw, I used to what did I do? I just used that as basically as a blind command invocation. That scheduled task invoking PowerShell was as simple as it looked, and from there that allowed me to invoke arbitrary blind commands. I couldn't see the result, which was fine, because at the end of the day all I wanted it to do was kick off certain string of commands that would launch an interactive session on a certain IP for me. So it's pretty much that. When you pull out junk through DNS, do you do anything to secure it? I probably don't want to dump credentials over default DNS requests. That's exactly right. You do not want to do that. You absolutely don't want to do that. That is not cool. And this is exactly the kind of thing that people should be very conscious of when they're using any channel like this, particularly if it's monitorable. So in my case, no, I do not pull anything out through DNS that is sensitive without it being encrypted. So for example, I wouldn't even consider pushing things like credentials or sensitive sort of plain text over DNS. But in the case of files which can contain sensitive information, those files are encrypted on the client using a set of parameters, encrypted on the client and then sent over the wire encrypted and reassembled on the server side. And then on the server side, I as the controller of the server have the means to decrypt that information. Another thing to consider, particularly if you're using an approach like this, that you worry about where you're actually writing the data to. And this is something that I've talked to a few people about, because I really don't like the idea of taking any form of client information and writing it to cloud storage. You've got data sovereignty concerns. You have, if you're writing data to disk, you don't know where it is. You don't know how it's replicated. You don't know if you shut down a cloud machine, that whoever spins up the next cloud machine isn't going to get the same bit of disk that you had before, and that they can read the contents off it. So yeah, things like that are an absolute concern. And so don't write stuff to cloud storage if you want to do the right thing by your client. That's probably something that I'm going to write a blog post about down the track, because there is a method that I used to get around that I've bounced off a few security folks that I hold in high regard, and so far the feedback on it's been positive. So I might even consider publicizing that and getting more and more people to comment on that. That would be good. Peleus, I absolutely have. I don't use AES though. So what I do is encrypt it with a public key and base64 it. So the content of the file is encrypted using a public RSA key. I'm the only one who has the secret key, and so once that file's encrypted, it is base64 encoded in chunks, and then I should say a chunk of data is taken out, a bit of metadata to that data is added, and then it's base64 encoded, wrapped up in a DNS request and sent across the wire. So that means for me that I have the ability to add some metadata to keep track of which chunks of the file are actually coming out and which are not. So yeah, look, I took the approach with the public key thing because, well, for one, to do this kind of stuff, first of all, you have to have something that is DNS aware running on the target. So that is, you've got some code already running on the machine. It's not just a straight PowerShell invocation. This is something that you've already uploaded, and that is either sitting on disk or something else. But you've got a program that's running that knows how to talk your protocol to your DNS server. So at that point, you kind of have control over what keys you do and don't use. I would much prefer to avoid shoving a binary or a PowerShell script over onto a client machine that has a symmetric key which can be snaffed. It could be snaffed off the wire as you're uploading your stuff as well. You just don't know. So I mean, if I'm going to put a key up and it's part of a binary or a program that I already control, then I have no problems pushing a public key up there, knowing full well that can't be used to pull any content out after the fact. Oh, did we just lose Peleus? I must have insulted him or something. Yeah, I get a thumbs up from the Ginger Ninja for the asymmetric crypto, and for exactly that reason. You don't want to have someone thieving the key off the wire and abusing it unnecessarily or whatever. Okay, so that is fundamentally a really, really trivial blind command and control thing that you can do on Windows machines. You can do the same thing on a Linux box. Obviously, your cron job does an NS lookup and parses the output in a trivial fashion and then invokes that as a command. I just decided to show you on Windows because it's scarily simple to do. And as a result of that, like you effectively have some kind of remote CNC. Now, what you should consider doing as well, not just in the opposite direction, that is that the data that you're sending back down the wire, the commands that you're sending back down the wire, you should seriously consider encoding/encrypting in some way, having some way of validating the content. So for me, and this is something that I haven't done yet, and part of the reason for that is purely due to the size of DNS requests, and this is something that I'm going to be working on in the next version of the DNS server that I have running. That is the ability to pass in arbitrarily sized payloads and still have something at the end of it that, like a HMAC or something, that can validate that it's come from the server that it's intended to come from, so that some other man in the middle can't hijack your DNS response and end up executing commands on your client's machines. Let's see. How would you suggest solving this problem for the blue team? In the past, many allowed incidents to resolve DNS. Guess it doesn't help much once you've got creds. No, it doesn't help much. Plus, you don't really care whether you're operating under the current context of the user. So, I mean, if you're doing DNS-based lookups under the context of the user, then all of those validations and proxies and whatnot become moot because they're still going to get out. Even if you're resolving via an internal server, that internal server at some point is going to go, hey, you want to talk to this domain out here on the internet, it's eventually going to reach a DNS server like yours that is the single authority for DNS requests for your domain. So I don't know, how would you solve this problem for Blue? Just, have some smart monitoring over your DNS requests, really. I mean, it's exactly the same as, in my view, looking at certain behavioral patterns via HTTP. I mean, are you seeing a request happen every 5 minutes? Are you seeing activity on a machine that's making that request every 5 minutes as soon as that DNS request is made? I think, for me, the kind of advice that I would push down the neck of clients of mine who have this vulnerability, for want of a better expression, is just do a much better job of monitoring DNS. Things like Splunk have fantastic support for DNS-based queries and alerts. And it would just take a little bit of time for you to configure Splunk or whatever else it is that you decide to use, like hone it to a point where you can actually pick up anomalies in your DNS requests. There you go. Atari's got another good suggestion, actually using things like OpenDNS. Stuff like that. I mean, you can even do, don't forget that when it comes to exfil or CNC over DNS, there's not really a lot of wiggle room. And so usually your TTLs are really low. So that's a sign. Usually, if you give a shit about DNS, your TTLs are going to be a lot higher than 5 seconds or something like that. So you'd be looking for things like low TTLs. You'd be looking for common base domains where the requests for the subdomains are really long, or obviously base64 encoded or something like that. You might also look at the DNS protocol itself and see whether or not there are bits being tweaked along the way that is a truly surreptitious DNS CNC, which is incredibly slow. But again, people do that kind of stuff all the time. So I don't think there's a good quality single shot solution for this. It would be a case of get to know what is normal for your DNS based traffic in your company, and then start setting up alerts for those anomalies and educate that and yourself over time. But if you get to that point and you're able to pick up those anomalies, even if you get some false positives, those false positives are worth it, and they would most likely be few and far between as you do a better job of figuring out exactly what the normal behavior in your network is. Hey, Multi. So that covers like the really basic CNC. Don't allow DNS and force everyone to remove. That's a great idea. I think I'm going to put that in my next report as far as remediation goes. Remove DNS, or just push massive host files out to people. That would be good. If you're using a load share, would it affect the end result you're trying to achieve? A load sharer. Not sure what you mean by a load sharer, Null. Do you mean like if you had multiple DNS servers, or you had multiple IPs or multiple domain names, or something similar to that? Is that what you're talking about? I would assume that's what you're talking about. I don't think it affects anything. You would just have to do a better job of multiplexing the results back together. You see what I did there? And once you've got that going, I don't think it really matters too much. Captive DNS systems work okay if you just need to limit the names looked up, but it won't work in all environments. Right. So it is 9:15. We've been going for about an hour and 3/4. We can try and extend this a little bit so that we can build a client that's able to talk to this server, and there's like a very, very simple protocol for pushing the results for a command back out. Do you guys want to have a quick look at how we might do that? That's probably going to take another hour and a half, or should we put that into another stream because it's already getting on? I'm voting that we stop the stream here because we're getting close to 2 hours. And then next Tuesday we can pick up where we left off here, and we can start baking in some back and forth and looking at a potential way of encoding the results inside the domain name and going from there. Yeah, I'm getting part 2 on another session. Yeah, big thumbs up from me as well. Okay, so look at that, another stream. This is as if you guys are sick of me, which makes a lot of sense. Okay, so I will make this code available for you guys to have a play with. I might just chuck it up on a GitHub repo and link it. I think, yeah, look, like I said, take this stuff as really small building blocks for something that you can build yourself. Give you an idea of what kind of things are involved, the options you've got available, and how simple it can be if you don't really give too much shit about OPSEC. If you're going to do stuff like this on client sites, you should be doing way more than what I'm demonstrating here. But hopefully this is opening the doors a little bit and giving you guys some ideas to think about. And then next week or possibly the week after, we'll pick up where we left off. We'll get some back and forth happening, and then off the back of that, I'll show you again how you might do something like saying, hey, there's a God knows how many gig file sitting over there. I want that pumped out through DNS as well. Okay. What Vim plugin for Go do I have? That's a good question. Just give me a sec. Oop, that's not what I meant. Bundle. Here you go. So this Vim Go would be the name, which actually is really quite nice, and it works well cross-platform. But most of these I don't actually use. I'm a big fan of Buffergator, Syntactic, Nerdtree. Vimgo is nice. Vimerl is nice. Zencoding is nice if you're doing various HTML-based bits and pieces. But yeah, that's effectively it. Thanks, OJ. Yes, Wibble, you're absolutely welcome, mate. Thank you very much. Same with you, Ribis, and everyone else, listener who's listening. I appreciate you guys coming along and giving me your ear, your eyes, and participating. And yeah, thanks. Sing out on Twitter or IRC or whatever form people have me on. I'm more than happy to answer more questions, and hopefully from here we will we'll be able to build something a little bit more fun. But you know, take these basics and go and have some fun with it. All right. So love you all very much. Peace, and go and enjoy another cup of tea. Cheers.